Now, in this video, I'm going to explain an intuitive way about how this large language model works on the web page. Okay. So this starts from 2022, November 30th. That's when the ChatGPT came into being, and we're all amazed by its existence. So it passed Turing test, and when we saw it, we think, oh, we do not even know who are we talking about, and the opposite of your computer. So this is certainly a game changer, a paradigm shift in many perspectives, not only in computing, but because we start to feel there's a human that can be our assistant. Although it's not human, it's a cyber human, but we do think maybe it will not be the same anymore. So how does it work back in 2022 November? And also probably still most of the days. Now we still use web page to talk to the large language model in order to get some information. Right? Many of us just use it as a way to, for example, a search engine, right? Or just as a way to quickly fix some issues. As long as the task is not big, using a web page based AI will be very handy. It's quick. You don't have to do all the setup. They're just there, ready for you. Now, LLM as a chatbot in the beginning. So what does it do? And what do you see? What you basically see is a text box when you type your words or say or formally queries. And then you see a chatting bubble coming from the model and show up on your screen. And the reality is the chat interface is a user experience layer that is wrapped in the raw neural network. So what you see actually is not what is going on under it. Actually, we do not see what is going on under the layer. But we're all familiar with this type of chatting. When you use WhatsApp or WeChat to talk to your friend, this is basically the back and forth. And ChatGPT, in the beginning, they use this kind of pattern in order to make us familiar with this kind of experience so that we'll feel comfortable and as if we're talking to a human. So user, that will be you say hi, and the assistant, that'll be the LLM, will say, hello, how can I help you today? And so on and so forth, something like this. Now, today I'm going to, in this video, explain what is going on behind in a very intuitive way. So if we consider this type of a conversation as a function, so the input is what you type, the output is what it says. So you typing will provide this kind of words or strings. They called a prompt right here. So prompt is something you typed and give it to the model. And the model will use it as an input. The model itself can be viewed as a function, and then it will emit or just say many other words to answer your question. That's called the response. So if you see LLM as a function, it has an input, it has an output. So how does this going to do on the cloud, right? So your model is certainly not on your computer, okay? Instead, it's on the cloud. How does it work exactly? I'm going to explain this step by step next, okay? So first, as a user, you type hi. So this is hi on the interface, or let's say on the web page you opened. On your local machine, you type a hi and then you press enter, and that hi will go to be composed by your local browser. Your local browser will read this hi, but then pack it in this JSON format, this language. And the local browser knows that, oh, you're going to make this inquiry to GPT-4o, for example. And then the message has is, we know you're the user, and in this content, you type hi, and some other metadata, for example, temperature. That is the way to adjust how the model performs, but it's not important. The important thing is there are lots of parameters that need to be passed on. The content that you just type is part of it is right here. And this is indicate you said hi. So that's what a client do. That is basically say your computer do, right? This is your computer do this, and based on your browser, and they pack up a long string, including all type of information. And then this type of information from your browser will be uploaded through internet to the server. Okay, the server here, let's use ChatGPT as an example still, after all, is the OG. So it goes there, and what's it see is this type of information has been passed on to it. Okay, but the GPT is not really trained on this type of a format. And what it's going to do is on the cloud, they have own machine that's first to translate this type of information to some information that GPT is trained for. Okay. And the current GPT is not necessarily this format, and the other model is not necessarily that format either. But this step is simply to translate the internet JSON format of this information into some format that their LLM can understand. This step is machinery, so it's quite straightforward. But you probably also see that on the cloud, the server also injects some called a system prompt. A system prompt actually is a way to maintain the integrity of the LLM. That you cannot use LLM to make guns, you cannot use LLM to make illegal drugs, and you cannot use LLM to do some nasty things that they think you should not be doing. So they have system prompt that's added in the front. Actually, if you search internet, there are multiple ways to jailbreak, but it's kind of getting better and better over the time. The system prompt is getting more secure over time. So usually we cannot do that. So the system is trying to make sure that the LLM is doing the right thing. So this part we do not have control if you do on the web page. But if you do on the API case, you have more freedom, but not total freedom. You have more freedom. Now let's come back to the web page based talk. So when you put this information, and the information will be translated and transferred to internet to the server, and the server will add a system prompt in front of your user prompt. So this form the whole prompt sequence and then fed to the LLM. Okay. So when the LLM see this long sequence of string input, what it's doing is only one thing, just predict the next token. Loosely speaking, you can say next word, but it's not necessarily the same. But let's say predict the next word. Okay, it's going to predict the next word. And then what is highest probability? For example, if hello is the highest probability, it's likely to be chosen. Okay, so if you say hi, was actually the background is doing a lot of things, work, wrap, upload, inject, and give it to LLM, and in the end, you get hello. So many work just to get a hello. Okay, so that is working behind. And when it decide to say hello and think it's time to finish, then they start to pack the information back. So when the information back, you see this is the JSON format that is from LLM. It's going back to you. This choices means it's high chance of 98.5. So we just choose. So that is called choice. We choose hello. Okay. And who said hello? The role is assistant. This assistant means the LLM. So the LLM says hello. And why is it finished? Because he want to finish. It's called stop. And there's some other finish reason. This belong to the metadata sequence. So that is not very important for today. So it's you said hi, he says hello, and everything going on behind. And this is LLM calculation. And then it passed back to your local computer, and then it's through the internet, come back to your machine, and then on your local client, it reads this and it extracts this hello and put it in the conversation bubble. So you see that hello. So this is how this LLM works in reality. Now, what's in summary? Let's look at the summary. Okay. So input, this is you type hi, and then your client app that sits on your computer, that's going to wrap your query into a JSON payload. Let's just say it's a string, and then it's encoded on the API backend, and then the system prompt will be injected and translated the JSON to raw, this kind of a chat ML tokens, say tokens. Okay, and then this whole sequence will be fed to the model. The model takes a sequence of strings and spit out a sequence of strings. Right, next token will come out, and then when it finished, the finish is also a token. So when it's finished, then the API backend will start to pack the whole sequence of the output and send it back to you. And then when it comes back to you, you unpack it and says, for example, hello on the screen. So this is what it's basically doing. So user is you. This client, let's say that's your laptop, right? That is what happened on your local machine. And this is API backend. That means you need a function to make some translations between your client and the model. And only step 4, you need the large language model, the LLM. Okay, the LLM takes some input, gives some output, and then you are able to see as a human through these steps of translations. Okay. So what does this brain actually do? It do one and only one thing. It makes the next token prediction. Okay. It takes input as a sequence of tokens and it starts to predict the next token. And after the next token is predicted, it add this next token to the previous token and make this whole sequence one token longer, and then make the next token and keep predicting until he reaches a stop token and everything will stop. And you get a sequence of output that's given to you. Right? If the model is weak, this type of prediction usually is not ideal. But luckily, the current models are so strong, the brain is just really good at it. That's why we see so many amazing things. And the key milestones to achieve those amazing things are a couple of. One is called the scaling law. You probably have heard it from many news already, right? So you have so many parameters, so many data. As long as the infrastructure is well established, you can have this good output, even better than human expected at the beginning. Okay. And during the scaling law, you can see many emergent abilities. These emergent abilities usually is to say, usually, okay, we cannot imagine this model can really respond to people, but all of a sudden, people start to feel it respond to people as a very smart human. This emergent ability is more like a human feelings. The ability is always there. There's just sometimes if you look at this quantitatively, it may not be that strong, but when it passes a certain threshold, it looks like, oh, a sudden ability appears. It's called emergent ability. And another milestone for this LLM is a chain of thought. People can give it instructions to let the model to show steps and really short steps. Actually, that means when you train the model already know chain of thought. It just you need the proper prompt to activate it, and then it can perform a better work. And those are actually the ancient concept. If you look at these papers, 2020, 2022, 2022, according to the AI time, this is quite ancient. So from what we understand, the mechanism is that model is stateless. In human language, it has no memory, right? So we understand this mechanism working behind. If you just type hi, it only take hi as the input. If you do that again to ask hi again, then it still answer your hi, but it doesn't know you already said hi already, right? For example, if you say my name is Yong, and it probably say hi Yong, but if you have another inquiry said what is my name, it doesn't know. Okay, so how to make it look like it has a memory? we have to give the entire history to it so that it understands. For example, in the first round, you said, "Hi, my name's John." And the assistant or the LLM said, "Hi, John." So this is what it looks like. Okay. First, in the round one, you have a system prompt that is LLM compulsory requirement. That's what it says. And as a user, this is us. He said, "Hi, my name's John." That's it. And in the second round, you already know what the LLM tell you. He said, "Hi, John." But instead of only asking what is my name, we also need to pass the full history of our conversation back to the LLM. So that means you should give, "Hi, my name's John," and this AI response, "Hi, John," together with "This is what's my name" to the LLM. Then the LLM will read everything here. Then he can extract information that, "Oh, your name's John." If you do not give him the middle two lines, it certainly doesn't know you. Okay? So you start a conversation on the web page, one and one and one, and keep going. As you can see, that's why we need a context window. Okay. If you do not have a very long context window, it may be misfunction, it may be truncated, it may be only read the last 50, so it forgets your name. So that's model context related problem in many of the early stages. You may realize that sometimes information is hard to find. This is called needle in the haystack or lost in the middle. So you have a very large context. The model has hard time to figure out what is happening in the middle. Ironically, this is just like a human, right? So if you read a book, for instance, or read a novel, it's very easy, probably much easier to understand the beginning and the end. But in the middle, it's harder, right? The LLM is just like a human in that way. So if the context is very, very large, also instruction drift, okay? So the model may forget early constraints. That is because when the context is long, it tends to focus on the later one or even do not have the ability to see the very early stages. So it come back to what is supposed to do by default instead of looking at your particular instructions. And also sometimes when there's some logical conflicts happened, because the model also is random, it takes probabilities to get the next token. So there's a chance to be self-contradiction. And if such contradiction happen, it's likely to happen in the same conversation again because it's already messed up, right? Think about if you educate some student with wrong instructions, with the wrong problem set, then he's likely to be confused and he's likely to be confused in the future. So this is also a self-contradiction issues. And the last one is called persona decay. So this is like you tell him, "Hey, now you're a useful assistant." This useful assistant is actually your part of the prompt. If the prompt getting way much longer, the initial one may also be truncated off. So this is context issues. Everything here, you do not have to remember those names per se. It's just all related to context. When the context is long, it becomes problematic. That's why people are doing research. Number one direction will be how about we make context longer? And number two direction will be how can we use an efficient way to compress some of the context without losing performance. Okay. So this is about how this basic works, and we can talk about context and harness engineering in some other video.